Good evening, everyone. Welcome back to the another project presentation by 360DigiTMG. I'm handovering this to Ashwini. Ashwini, please continue the presentation.
Hi everyone, this is Ashwini and welcome to project presentation on named entity recognition on medical journals. Before we proceed, I would like to thank our project sponsor and client Sharat Manikonda, project manager Raju Kalyan, and our mentors Pavani and Gomati for guidance in successful completion of this project. I would like to introduce the rest of my team, which comprise of me, Akshay, Vijay Gauri, Anjum, Maji, Ashish, Komal, Mamta, Jabir, Noori, Zaid, Pathak, Panchanand, Pranay, Rajesh, Rishi, Pallavi, Rituraj, Sagar, Sai Rahul, Vijay, Vijay Krishna, Ashpak, Rutuja, Dhruva, Emmanuel, Dheeraj, Ricky, and Sachin. Let us look into the contents that we discuss in this presentation, starting with project overview and scope, project goals, CRISP MLQ methodology, technical stacks, project architecture, input to output, named entity recognition, data understanding, data preparation, model selection and building, output, deployment, conclusion, model evaluation and fine-tuning, and future scope. Let us now look into overview and scope of this project. With recent growth of technology and vastness of medical field, we find a lot of medical journals and articles related to many diseases and drugs written after a lot of research. The main purpose of this project is to extract different entities from those medical journals. Entities such as diseases and their respective drugs, dosage, frequency, and composition of the drug are extracted using this model, thereby reducing the manual efforts of the domain experts and researchers. Next comes the objective of the project, which is to maximize the number of correct entities that are being extracted from the medical journals and also to minimize the errors during the extraction and time needed for extraction. The constraints we anticipated for this entity extraction are that it is difficult to recognize medical entities among other entities. Let us look into CRISP MLQ methodology we followed for this project. First comes business understanding. Next is data understanding and preparation, model building, model testing and evaluation, deployment, monitoring and maintenance of the project. Business understanding is the initial stage where we understand the client requirements and the data provided by the client, which in this case is in the form of medical journals provided to us in the form of PDFs. Data engineering and data preparation is the stage where we take the required features from the data provided by the client. This also includes cleaning of the data for stop words, punctuations, and also tokenization and lemmatization, etc. In model building stage, we take the clean data and build a model for extracting different named entities from the input medical journals. In the next stage of model testing and evaluation, we check the accuracy of the model and also the performance of the model. The next stage is deployment, where we use Streamlit. The built model is loaded and run via Streamlit to get desired output from which we can download the named entities extracted. Monitoring and maintenance of the model is carried, such as feeding new PDFs to the model and checking for accuracies from time to time, depending upon the client requirements. Let us look into the technical stacks that are used. We use Python language for EDA and model building. Jupyter Notebook and Google Colab were used as IDE for Python. We use different libraries such as PDF Miner, NLTK, and Spacey. Also, we use Med7 pre-trained model. Let us now look into project architecture. First is data collection, where we collect the data provided by the client in PDF format. Next is data preparation, where we extract the PDF files using PDF Miner. And the next step is feature engineering, where we pre-process the data like cleaning for stop words, punctuation, and performed word tokenization and lemmatization. Next is model building, where we use Spacey library and Med7 for extracting different medical terms from the PDF. This model has been deployed on Streamlit and the final output is downloaded in CSV format. Let us now look into input and output. Here, we have given the input in the form of PDF to the model and we get the output of drugs in CSV format. Now my teammate Vijaya Gauri will take over from here. Thank you. Over to you, Vijaya.
Thank you, Ashwini. In this project, we are using NER and MED7 models. Now we look into NER, named entity recognition. NER used in many fields in natural language processing. In field NLP and information retrieval called name entity recognition, and we can apply it for textual data to extract chief entities. Named entity recognition is a subtask of information extraction that seeks to locate and classify named entities in text into predefined categories such as the names of persons, organizations, locations, percentages, etc. These are comes under general named entities. In this project, we are applying NER on medical journals. We can categorize this under domain-specific named entities. The challenge in NER is to minimize the ambiguity and abbreviation. That is to extract the entities accurately even if it's usually generated by combining Greek and Latin roots and affixes. Now we look into the data understanding. We have to understand the data, what type of data we are using. It is structured format, semi-structured or unstructured format. In this project, we are using unstructured data, which is in the form of PDFs and Word documents. Our main focus is to extract maximum entities. This can be done through NLP by using NLTK and SPACY library. Now we look into the data preparation. It is a process of manipulating raw data into accurate form to analyze. It comprises of basic text cleaning and removing unwanted text and standard escape sequences. Word tokenizing and stopword removal, lemmatization will improve the accuracy. Word cloud is used to visual the representation of extracted drug entities. Now we look into the libraries we use to build in this model. NumPy, Pandas, SPACY, Encore, Med7 lot. NumPy is a library for the Python programming language. It also has functions working in the domain of linear algebra, Fourier transforms, and metrics. It is used for a large collection of high-level mathematical functions to operate on the arrays. Pandas is used to read or manipulate data frame. SPACY is used to build an NLP model to extract the features. Encore Med7LG is used to extract specific medical entities such as drug frequency and its composition. Now we look into the Med7 model. Med7 is a transferable clinical NLP model for electronic health records. This model takes clinical names like medication and its related entities. This model can be installed and used as a part of SPACY library in Python to perform clinical named entities. This Med7 model is trained on Mimic3 free text electronic health records, which is able to recognize 7 categories as shown below. The named entities are dosage, which is total amount of drug administered. It could be a sliding scale, tapper, bolus, 30 ml. Drug, which is generic or brand name of medication. It could be aspirin, prednisone, vitamin B. Duration, which is the length of the time the drug was prescribed for. It could be 3 days, 7 days, or 5 more days. Form, which is a particular configuration of drug which is marketed for use. It could be a tablet, capsule, solution, with device. The next entity is frequency, which is dosage remain at which the medication should be administered, which could be once a day. BID, which stands for twice a day, and 6 hours as needed. Route, which is the path by which the drug is taken into the body. P.O. by mouth. Nasal cannula injection. Strength, the amount of drug is given in dosage. It could be 5 mg, 100 unit per ml, 50 mg per 2 ml, etc. This trained model comprises of 3 components in its pipeline: tagger, parser, and clinical NER with 7 categories. Now we look into the data set that used to train this Med7 model is from Mimic3 medical information masked for intensive care 3. The data is a part of track 2 of the 2018 National NLP Clinical Challenges shared task on extraction of drug related concepts, including adhesive drug event and reason for prescription. The data set is comprised a collection of discharge letters from the ICU and contain very rich detailed information about the medications used for treatment. Also, other documents from the UK CRISP platform and NHS were used to train the model. In this model, the total 303 documents are used for trained data and 2 for test data. Distribution of drug annotated entities and the text summary statistics of the training and testing data sets is completed by lowercase in words. Next, we will look into the result from the MED7 on the text data on 202 documents is divided into two metrics, that is strict and lenient. Strict metric account only for exact match in both the surface string and the corresponding label. Basically, the annotated text and the ground truth should match 100% each other. Whereas the lenient metric allows for the partial match between the ground truth and the annotated text. Now, if we look into the result as over here, this model can achieve 0.893 micro average F1 score and 0.863 macro average F1 score on the test data set, which is a strict F1 score. Now you look for the lenient F1 score. It gives 0.957 micro average F1 score and 0.947 macro average F1 score. My teammate Pallavi will continue next. Pallavi, please take over. Thank you.
Thank you, Vijaya Gauri.
Pallavi, please unmute yourself.
Thank you, Vijay Gauri. Now let me start with model deployment. The database that we have used in this project is MySQL to store output obtained in CSV format. MySQL is an open source relational database management system. It works with an operating system to implement a relational database in a computer storage system. Manages users allowed for network access and facilitates testing database integrity and creation of backup. It reduces the network traffic and easy to maintain. The output obtained from model will return a CSV file and contains entities like drugs, frequencies, and route as column. The data from CSV file is uploaded into a database. Based on the requirement, user can decide which all entities they need to retain. Based on this query, data from database is displayed. The framework that we have used in deployment is Streamlit. Streamlit is an open source Python library that make it easy to create and share beautiful custom web apps for machine learning and data science. When a file is uploaded, it takes input from the uploaded files such as text or any other data form of data. So here we upload the text file and text will be provided as input for MED7 model. The MED7 model will recognize the entities. User can also specify the required entity based on which the entity will be displayed accordingly. As a part of the data preprocessing for next data, we are doing a word tokenization. Word tokenization is an essential splitting of phrase, sentence, or an entire text document in words as tokens. Here, we are splitting all text documents into words, which helps us to identify the medical terms easily. We import word tokenizer from NLTK library. The next preprocessing method we have used is lemmatization. Lemmatization is one of the most common text preprocessing technique used in NLP and machine learning. Lemmatization actually converts the words into a base form by cross-checking with the dictionary. For example, the words bills, billing, or built or to be reduced to lemma, built. We import WordNet lemmatization from NLTK library. In addition to this, we have also done stop word removal, punctuation removal, etc. as a part of cleaning text data. As a pre-trained model in SPACY, similar to MED7, but it extracts only chemicals and diseases. But as we know, the drugs are made up of chemicals. So it extracts drugs too with better performance. And also, we have used MED7 To get more accurate drugs by Med7, it labels the names of the drugs are present in the text. This is our final output, which entities labels the start position in the text and end position in the text. Where the start position and end position of the entity will be easy where the entity is present in the text. Streamlit is an open source Python library that makes it easy to create and share beautiful custom web apps. We can create web apps in 4 steps using Streamlit. The first step is to create a new Python script. In Python script, we have to import Streamlit. After then, we have to design our web page with the title, background design, and so on. At last, we have to run Streamlit from the command line. Streamlit run Python script name. Coming to more product demonstration, here we have drag and drop option. We have to drag the text file. Then we have to specify the entities, whatever we want to demonstrate. After that, it processes a text file at backend and gives the entity an entity name. And we can download that file. There is another way of deployment. Next, my teammate will take forward. Over to you, Nuri.
Thanks, Pallavi. Yeah, here another model is taken, that is custom NER model. This custom NER model we have created for developers so they can iteratively tag, train, and evaluate and improve model performance before making it available for consumption. The quality of tag data greatly impacts the model performance. How the custom NER project works is a brief explanation is about the life cycle. Here we have taken define schema, tag data, train model, view model evaluation details, improve model, deploy model, and classify test. Let us explain each in detail. Next slide. Next slide. Next slide. Next slide. Yeah, let us explain the what are the custom NER typically involves in this. First, we have to define schema, know your data, and identify the entities you want to extracted. Avoid ambiguity. What is ambiguity here? Ambiguity can refer as ability of having more than one meaning or being understood in more than one way. So we have to avoid that in NLP. So we have taken the original data as PDF file. Let that PDF file, we have to tag our data. Tagging is a key factor in determining model performance. Here we have taken the tag data as drug entities. Then we have to tag precisely. What is precisely? Tag each entity is to its right type always. Only include what you want to extract. Avoid unnecessary data in your tag. Then we have to tag consistently. The same entity should have the same tag across all the files. Tag completely. Tag all the instances of entity in your files. After tagging your data, we have to train our model. For training our model, we have to start learning from your tag data. Your model will start learning what you have given in your tag data. After the training model, we have to improve our model evaluation, and for that, after training is completed, view model evaluation details and its performance. What is meant by performance? Here, performance is for show less accuracy and less error and more accuracy. We have to improve our model. After reviewing model evaluation details, we can learn how our model has shown the details. After getting this improvement, we have to deploy our model. Deploying a model is to make it available for use. All these models can be used in hospitals, clinical research, where clinical feature of drug can be used in identification of huge unstructured data in medical records. Next slide, please. Here we have given the visualization part, how these entities are used in drug identification. Let me show this visualization. Here we have to browse our files. After browsing our files, we then we have to choose process, drugs, frequency, and all. When we choose process, then PDF file contains totally 2035 words. This PDF file contains 5 pages. When we want to choose drugs, then the drugs in these journals are shown here. When we want to choose frequencies, then the frequency of different drugs are taken here. Then we want to show the combination of both frequency and drugs, then we choose all. Then here drugs with frequency are shown in these journals. Then we want to show NER recognition from the test. The test we have taken from any of the Google, then we copy this test here. Then we want to paste here. Then we want to predict the NER from this given test. Here it shows that clearly shows that aspirin is a drug from the test given. If you want to show drugs description, name the drugs used in these journals. What are the drugs used here? We can choose anyone. We can choose aspirin. Select which type of information you want to see. If you want to see description, reviews, or rating regarding to these drugs. If I choose description, then it will show description of aspirin. Then if you want to choose reviews, then reviews are shown of aspirin. It is an easy way to communicate the end users. Next slide. Next slide. Yeah. While after completion of this data visualization, then we have to connect this data. We have to store in our database. We have chosen MySQL database. Why we have chosen MySQL database is MySQL is a relational database management system based on SQL structured query language. Python can be used in database application. One of the most popular database is MySQL. MySQL is free and open source. It is ideal for small and large scale applications. So before connecting with Python, we have to install our MySQL driver. Python needs MySQL driver to access MySQL database. Start by creating connection to database. Use username and password from your database. After connection to our MySQL database, we have chosen MySQL Workbench and MySQL Command Line client. Here, MySQL Workbench enables us a DBA, database administrator, developer, or data architect to visually design, model, generate, and manage databases. Here, MySQL, we have two types, developer and administrator. In developer, we can write delivers visual tools for creating, executing, and optimizing SQL queries. What has the administrator done is MySQL Workbench provides a visual console to easily administrator MySQL environments and gain better visibility into database. Then next, we have to see how the MySQL Workbench and MySQL Command Line client will work. Here we have to give our password. After entering our password, then we have to show our databases. What are the database in our command line? here, after we have to use our own database, that is I have chosen Nuri. After using this, we have to show the tables in our database. Here, these are the 4 tables inserted in our rows, in our table, that is rows and columns. If you want to choose a specific data table, we can choose select star from that journal name, and then we have to enter. Then it shows the drugs with frequency in the specific table. From this MySQL command line is a simple shell with input line editing capabilities. It supports interactive and non-interactive use. When used interactively, queries results are presented in ASCII tabular format. When used non-interactively, the result is presented in tab separated format. Then next slide. Next slide, please. Yeah, let me explain this MySQL with Workbench. I already discussed that MySQL Workbench enables with the developer side. We can easily execute and create our tables, and we can write our SQL commands. Let me explain MySQL Workbench. Here, the same query we have shown here, like a shell. Command line client is also known as shell. The same we have to use here. Show databases. What are the databases in our Workbench? Then use our own database, which I have created. After we are using this, then what are the tables inserted in this database? Oh, these are the tables inserted in our database. We can choose a specific table by giving select star from, it is a SQL query, select star from specific table, then press enter. Then we have shown the drugs and frequency of this specific journal. We can take another type of journals. We can choose any one. The results are shown here. We can choose results from this table. Okay, then we have taken this journal name. After pasting here, we can press then drug and frequency of that specific journals are shown here. Thank you. Next continuation is done by Emmanuel, and I will hand over to Emmanuel. Thank you 360 for giving this opportunity. Thank you.
Thank you, Nuri. Hello, everyone. Let us conclude our project. NER model for clinical concepts in unstructured medical records recognizes 7 categories. One is drug, their names, dosage of the drug, and the form of the drug, their strength, and the route of the administration, prescription, and the duration, and also the frequency. In detail, it is a process where the algorithm takes a string of text and identifies relevant entities that are mentioned in the string. The techniques for creating the NER system from manual rule-based assignments provide good and accurate results. Next slide. So if you see model evaluation and fine-tuning, so we have used to evaluate the model accuracy feature extracted by the model on our data, we need to annotate the documents with the help of domain experts. And also for the text cleaning, word tokenization, lemmatization, and some other methods are also used. Next. So if we talk about the feature scope, different journals can be used as an input to extract the entities and retrieve the information. The drug extracted can be linked to a site that gives more information like the uses, side effects, alternate drugs, etc. So information gathered from the journals can be used to validate the new journals of its content. The entities extracted from the different journals can be used to find new information about the entities. So that's all about from our side. If you have any questions, Please post your questions in the chat box. So I'll hand over to Panchana to take the questions. Thank you.
Guys, any question? I think we do not have any questions. Emmanuel, please continue then.
So I would like to thank all my teammates and thank you everyone for joining with us. Thank you all.